Here are some common mistakes that happens when people write write formulas. So like here, this is probably the number one mistake that we see when you need parentheses but you don't put them on there. So if you were to write a formula for magnesium hydroxide, you would go Mg 2 plus. You look up magnesium on the ion chart. You look up hydroxide, it's OH and it's 1 negative. Okay, the charges aren't the same, so you crisscross 1, 2. Now, when you rewrite it, you would go magnesium. Now you have to evaluate, do I need to keep the parentheses? Is the number bigger than 1 on the outside of the parentheses after you crisscross the bottom number? Yes, so you have to keep them. All right, because having the 2 there means there are 2 OHs. Okay, that means that there's an OH and an OH. And if you forget the parentheses, it would look like that there's one O and two H's. And that's wrong. So whenever you crisscross and the number on the outside of the parentheses is bigger than 1, you have to keep the parentheses. Here's another example right here with this aluminum cyanide. Let me see if I can make it. I guess I can't make it bigger, but anyway. All right, so you would look up aluminum and it's Al3 plus. You look up cyanide, it's a polyatomic, so I'm going to put it in parentheses. Cn 1 minus. You crisscross, and then you're going to rewrite. Okay, of course you don't write ones. Okay, but the Cn has to be in parentheses because the number on the outside is bigger than 1. You have to keep them. I don't know, for some reason when people see that the number like on the end of the polyatomic is just 1, they tend to like to forget the parentheses. Okay, another mistake that people do is they just think that they need to put parentheses on everything, like magnesium chloride. So people would go, okay, magnesium is 2 plus, chloride is 1 minus. Some people, I don't know why, but they just put everything in parentheses and they crisscross. Okay, things that are not polyatomic ions, like chloride is a single ion, don't put it in parentheses. Okay, you don't need parentheses. So you would just go 2 plus, 1 minus, and you'd crisscross. And so it'd be MgCl2. Okay, now this part number 3 is not simplifying ionic compounds after the crisscross. Okay, ionic compounds need to be in, the formulas are always written in the simplest ratio of ions. Okay, so let's just say that you did magnesium oxide and you went 2 plus and you went 2 minus. Now you should already see that because the charges are the same, the correct formula would just be MgO. But some people get all caught up in the crisscrossing and then they would crisscross and they would end up getting Mg2O. Okay, now that's not correct because that's not the simplest whole number ratio. You see, if you looked at the card, if the little card game that we did that one day with the blocks of wood, I guess. So if you have MgO, all right, you don't need two Mg's and two O's. Okay, you only need half of that MgO because 1 2 plus cancels out 1 2 minus. All right. Okay, the next one is tin 4 oxide. So when you have to write the formula for tin 4, you would go Sn, that's Roman numeral 4, 4 positive. Oxide is 2 negative. Okay, the charges aren't the same, so you could crisscross. And you would get 2 and 4. All right, but 2 and 4 can be reduced to 1 to 2. It's just kind of like reducing fractions. So you would get SnO2. All right, because you wouldn't need 2 and 4, you would need 1 and 2. So like if you think of it like this again, so like if you have the card, the blocks of wood thing, All right, so you wouldn't want SN, SN if each was 2 plus, and you wouldn't want 4 O2 or 4, not O2s, 4 2 minus O's, because half of it will work. All right, so you always, after crisscrossing, always make sure that you reduce to the simplest whole number ratio, 1 SN to 2 O's. That's the correct answer. Here's another one here. Lead 4 sulfate. So if you went lead, it's 4 plus, okay? And then you have to do sulfate, and it's a polyatomic, so I'm going to put it in parentheses, and that's 2 minus. If you crisscross, you get a 2 and a 4. But a 2 and a 4 can be reduced to a 1 to 2. Same thing with like manganese, Mn, 4 plus, carbonate, CO3, polyatomic, I'm going to put it in parentheses, 2 negative. So you crisscross and you get 2, 4. But that can be reduced to 1 to 2. So it'd be MgCO3, 2. Okay, a couple other things that people tend to make mistakes on with the naming. Okay, so like if you had something like this, Cu2O, and you need to write the name for that, you need to figure out what ion copper is. And so if you look at the period or the ion chart, you can tell that copper has a Roman numeral. So when you write the name, you're going to have to come up with copper. You're going to need to know the Roman numeral and then oxide. A big mistake is people somehow, their brain says, look at that number, but that's not the Roman numeral. The Roman numeral is the charge. That's what needs to go there. Okay, so you got to figure out the charge. Okay, now what does work a little bit, or what you can do, is you can think about the block of wood thing that we did with those cards, or the cards. And anyway, so I draw a rectangle and then I cut it in half. You can put the positive ion, you have 2 of them. So let's put 1, 2 of those on the left side. Put the negative ion, there's only 1 oxygen according to the formula. And then look up the charge on the negative, that's 2 minus. So 2 of these cancels out 1 of these. The net charge at the bottom is 2 minus. The total charge on the left has to be 2 plus, but you got 2 of these, so each one must be 1 plus. So the answer is copper 1 oxide. All right, let's see if I don't have a lot of room, but let's try one more of those. I'll do one at the top. This is a common mistake that people make. So like let's say that you had this one, like this one would be one that just kills people. SnO2. And you had to write the name for that. So we know that it's tin, so we write tin, but if you look up tin, it has a Roman numeral. So we're going to have to do that card thing, so with the thing to figure it out. So tin, Roman numeral something, oxide. So how I do it is I draw a rectangle, I cut it in half, and I count. Okay, I got 1 tin and I got 2 oxygen. So I'm going to put the oxygen here and the oxygen there. I'm going to look up the negative ion. That's -2. That's -2 for a net of -4. There's only 1 tin there, so it has to be +4. So it's +4. So the Roman numeral is tin 4 oxide. Okay, that's it on that video there. So hopefully that will help you.